Hello children. In continuation with the circle, this is our sixth lecture, and in this lecture we will see let's learn part of regarding to the touching circles, and we have to uh, use the to study this we have to use the activity. So first of all, here they told you take three collinear points x y z. So we have to take three collinear points x y z as shown in the figure and draw a circle, okay, with radius x and radius with center x and radius xy. Draw another circle with center z and radius yz, and note both the circles intersect each other at a single point, and that is y, okay. And draw line passing through the point y perpendicular to xz. Note that this is the common tangent of the two circles. We'll see this with the activity. So we'll see the activity. Now first of all, I will draw the circle with center x. So this is the circle with center of the circle is x. Now I will draw one more circle with center z, okay. So they are touching each other at one point, okay. So this is the another circle with center z. So this is the center of the circle and it is x. This is the another circle center of the circle and its name is z, and this is the point of touching to each other is the y, okay. Now I will draw the line which is passing from this point y, okay, and first of all I will join this x z, okay. Here is the x, and passing from x I will draw the line. This is still z. Okay, now this point x, y and z, they are on a one line. Now what I have to do, take three collinear points. The three collinear points are x, y, z, and as shown in the figure, draw a circle with center x. So here for the first circle, this is the for this first circle, this is the center x and xy is the radius, okay. And for the second circle, that is with center is z and radius is yz, that we draw, okay. Now next what they told you, note both the circles intersect each other at point y. So they intersect each other at point y. So here is the point y, this is the point y, and they intersect these circles to each other at point y. Next what they told you, draw a line passing through y and perpendicular to the yz. Now I will draw the line passing through the point. Now I draw here the line which is passing from point y and y, which is the touching point of these two externally touching circles, and it is perpendicular on this two. So it is perpendicular. Now if you notice here, you will understand that the line L is a common tangent of both the circles. These two circles are externally touching circles. Why? Because their point of touching is the outside the circle, means here it is there, okay. Why? So, and they are not means they are, so what is the meaning of externally touching circles? This touching circles, they are lying in one plane means they are coplanar on one plane. If you see here, they are on one plane and they are intersect each other at only one point, okay. So this is called as a touching circle. So from this what we understand, if two circles are in same plane, means here the circles x center with center of circle is x and center of z is the z, they lie on a one plane and only one point they are intersect each other in only one point. So point of contact is the y. They are said to be the touching circle. So x and y center, the circle with center x and y are x and z are the touching circles, and the line is common tangent, and this line is there. Suppose I will give name L. So this line L is a common tangent for this both circle, and the point common to the circle and the line is called as a common point of contact. So point Y is the common point of contact. After this we will see the externally touching circles we see. Now we will see the activity of internally touching circles. Okay, so for that, first of all I will draw the circle with so first of all I will draw the circle. This is the circle. Okay, now I have to draw the one more circle with, I will take the different color. So this is the another circle. Okay, now here is the another circle. If you see this figure, these two circles intersect each other internally at this point. Suppose this is the point, that is, so they touch each other at point Y. So suppose this is the point Y, and the center of the small circle is X. Okay, this is the center of small circle X, and this is the center of the big circle, and its name is Z, suppose. Okay, now if I will draw the here I will write the name Y. Okay, then here is the Y. Now if you see these 3 points are on a one line. These 3 points, so this point X, Y, Z are on a same line. So here what they told you, draw a circle with center Z. So this is the center Z, and this is the red color circle is the center with center Z. Now here we draw the one more circle with center X, and its radius of the bigger circle is the YZ, and smaller circle is the XY. Okay, now note the both the circles intersect at point Y. So they are intersecting each other at point Y. At this point they intersect each other. Okay, draw the line perpendicular to the YZ through point Y. So from this point Y we will draw the line which is perpendicular to this both the radius. Okay, now I draw the line L which is perpendicular to this point, to the radius of both the circles, and this line I will name it as a L. Now you will notice that for internally touching circle also what there is only one point is common in between the two touching circles, and if we draw the line passing from this Y, then it is a tangent for the circle. So line L is the tangent for the circle. Okay, now for first figure also, so this is the tangent, and for the circles which are touching internally, for the circles those are touching externally, for this also there is only one common point is there, and that point is the point Y, and what happens, it is the tangent for this circle. Okay, now afterwards, now we see this both the activities, okay, which were their circles touching each other externally, and the circles they are touching, they are touching each other externally, and here is the point of contact Y, and where from this point we can draw the only one tangent or only one perpendicular passing from the point Y, and which is perpendicular to XY also and YZ also. Okay, and for the externally touching circle also we can draw the only one perpendicular passing from Y, which is perpendicular to XY also and for YZ also. Now we will see Now here what we understood from this both. So see here that what they you must understood that the circle with both the figures are coplanar they lie on a one plane and they intersect at only one point with each other. They if you see here it's they here they touching each other at only one point, that is y, and for this figure also they touching each other at only one point, that is the y. They are on one plane. If you see this figure, this is also one plane and that is also in a one plane. Okay, so they are coplanar, they intersect each other at only one point, and such a circles are said to be the circle touching each other. So these both the circles are the touching circles of each other. Now touching circles can be defined as follows. So what is the definition of touching circle? If two circles in the same plane intersect, if two circles in the same plane in one plane intersect with a line, okay, with a line in the plane in only one point. So in our figure inside only y point was there, so they are said to be the touching circles. So these circles are called as the touching circles, and the line their common tangent and the line which is passing from this, it is called as a, this is the common tangent for this. Okay, and this in our figure inside here is the y is the tangent for this, this is the y and it is a tangent. Okay, and for this above figure also here this figure inside this is the tangent. Okay, so in this way we understand that if two circles are touching each other at one point, from that one point we can draw the only one common perpendicular, and that is a tangent for the circle. Okay, the point common to the circle, what they told you, the point common to the circles and line is called as a point of contact. Okay, so for above figure the y is the point of contact, and for this figure also which the y is the common point of contact. Okay, after that we will see this is the figure. So what they are asking, see here in figure 3.24. so figure 3.24 is here the circle with center r. So this is the circle, this is the greater one, this is the center r, and yes, okay, this is the center, yes, touch each other at point T, means they are touching each other at point T. So they are two touching circles. So which type of circles these are? These are externally touching circles. They are because they are touching each other externally. Okay, with the L as a common tangent. So this is the common tangent for this figure. Okay, R they are tangent, common tangent, they are touching externally. So they touch each other externally in this figure. Okay, after that we will see the figure number 23.25. For this figure what they told you, for this figure the circle with center M and N. So for this figure this is a circle with center M and the N. Okay, there are the two circles, and the center of the circle, smaller circle is the N, and center of the greater circle is the N. Okay, so touch each other internally, they are touching internally. If you see this, they are touching internally, means this is the first circle, and in that circle inside the smaller circle lies, means these both are occupy, they are touching internally to each other. Okay, and P is the common tangent for this. So for this both P is the common, this is line P is the common tangent, and K is the point of contact. Here point of contact is T, here common tangent is here. So for this figure if they are touching externally to each other, the common tangent we can draw the one only common tangent, and internally touching circle inside also we can draw the only one common tangent for this both. Okay, now we will see the next what we are thinking. So the circle shown in the 3.24 is called as a externally touching circles. Why? Because they are touching externally to each other, that's why we say they are externally touching. And the circle into 3.25 internally, because they are touching internally touch to each other. Now what they are telling to you, asking to you, in figure 3.26 the radii of the circle with center A, B are 3 and 4 centimeter. What way they told you, radii of the circle is 3 and 4 centimeter. So we will move towards upside. And again what they are asking, respectively find distance of AB. We have to find out the distance of AB. So radii of the circle with center AB 3 cm 4 cm respectively, and for this 3.26 they are touching internally and externally, that we have to see. Wait, I will show you. So here is the 3.26. okay, theorem of touching circle inside. So what they told you, see here, the distance of AB is how much? 3 A and B is 3 centimeter from the center is the 3 and 4 centimeter. So the distance radii of this AC is equals to what they told you from the distance is it is 3 centimeter. It is given here upside. If you see here, it's given here, that is 3 centimeter and 4 centimeter in the figure. A, B are from the center. So we will solve this example. You just move towards the figure. If you see here, okay, so AC is equal to how much? 3 centimeter, and BC is equal to how much they told you? 4 centimeter, and we have to find out the distance between AB. You are more talented. See here, how much is the distance between A and B? Just simply you have to add the distance of AB is equal to, you have to solve in this way. Wait, I will show you. So distance of AB is equals to distance of AC so distance of AB is equal to distance of AC plus distance of BC. Here I told you its measure is 3 centimeter, its measure is 4 centimeter. So I will write here 3 plus 4 is equals to, its answer is 7. So if the circles are touching externally to each other and we have to find out the distance between the center of this both the circle, then we have to do the addition of the radius of the both the circles. So for this, it is AC and it is BC. Okay, now if you want to find, so did you understand? If they are touching in external to each other, we have to do the addition of this both the radius, and for the another figure, if they are touching internally each other, then what we have to do? So when the circles are touching internally to each other, when we have to find out the distance between A and B, first of all we have to distance of AC minus distance of BC. If we done, then what happens? We will get the distance of AB. So distance of AC, this is equal to, it is 4 centimeter, and for this it is 3 centimeter. So we have to do the here 4 minus 3 is equal to 1 centimeter. Means when the circles are touching internally to each other and we have to find out the distance between the center of this both the circle, then we have to do the subtraction of the both the radius. Okay, now in this way, if we want to find out the distance of in the externally touching circle, we have to do the addition of this both. So 3 plus 4 is equals to 7, and here it is we have to do the subtraction. So here it is 4 minus 3 is equals to 1, and you have to use this formula for solving the example. Okay, in this way we will find the distance between the two circles when they are touching internally and when they are touching externally. Okay, after that we will move towards the next point of our next point. So what is that? If theorem it is there, if two circles are touching, touch each other, their point of contact lies on the line joining their centers. Okay, that, and its theoretical part it is there. So if you see here in the figure, you will notice that this line, let line L be common tangent. See here, this is the line L for this figure also. So this is the line L for this both the figures. This is and common tangent passing through point C. So this is the point C, and from that point C, this is the L is the common tangent we drawn. Okay, so if it is a common tangent for this, then you will notice that this line L, see here, this line L is perpendicular on AC. Okay, what I said, the line L is perpendicular on AC. Here also, this is line, suppose we join this, then line L is perpendicular on AC. Okay, same way this line L is perpendicular on BC also. So here it is already on one line, so it is perpendicular on BC also. So line L is perpendicular on AC, this line L is perpendicular on BC. Okay, then and again AC is not only the line is perpendicular, this AC is also perpendicular on L, and BC is also perpendicular on this line L. Okay, what I said, AC is perpendicular on L and BC is also perpendicular on L. Okay, so they are perpendicular to each other, and from this what we say that through the point C, one line perpendicular to the line can be drawn. Okay, so from this point C we can draw only one which is line which is perpendicular for this line L. So this point, that is ACB and ABC, are collinear. Okay, means they are lying on the one plane, and for this theorem we have to write only these three lines for the proof. So given inside what will come, C is the point of contact. If you see figure here, you will see this is the point C. Point C is the point of contact. Okay, and for the contact of two circles and with center A and B, C lies on AB, that we have to prove. And for that purpose, if you see here figure and this both, you will notice that, see here, see here, see, L is perpendicular on AC. So L is perpendicular on AC, then L is perpendicular on BC, L is perpendicular on BC. For this also AC, L is perpendicular on AC and L is perpendicular on BC too. Then afterwards AC is perpendicular on L. This AC is perpendicular on L. Same way BC is also perpendicular on L for this figure also. And afterwards what we have to show, that only one line perpendicular to the line L can be drawn from the point B, from the line. So C, A and B. C, A, B means ACB, and this C, A, B. These are the points which are, they are collinear to each other. In this way you have to complete this theorem. Okay, only three lines are there. So from this what we are understanding, that the point of contact, see here, the point of contact of touching circle lies on the line joining their center. What we understand, the point of contact of touching circle lies the line joining their centers. If the circle touch each other externally, what I said, if they are touching each externally, the distance between the center is the sum of their radii, that we seen that. Okay, and then when they are touching internally to each other, then the distance between their center is the what is equal to the difference of their radii, that we are understanding today. Okay, all of you understand. I hope all of you understand today whatever I taught, that you have to solve the practice set number 3.2. okay, and send me on my personal number. Okay, thank you.